Hi guys, I'll warn you we don't want to talk about AutoFixture, and I recommend to watch the video to end, and after that you can find a good approach to cover all the edge cases of the test that you have in your project. Exactly, the problem starts from this point. In the example based test, you can just hit some specific edge cases to your test input and test method, and maybe some edge cases can be forgotten during the writing the test. And for example, we have millions of possible inputs, but we just hit and pass one or two or maximum 10 input to the test method. So we can't 100% share our code works for every possible input. But what is the solution? The solution is, instead of writing the example in the test, we validate the invariants and rules of that method. For example, you have one method with name of reverse, which get the text as a string, and we reverse it and return it as a output to the user. One possible invariant in here can be, if we reverse one string twice, we should get that string again in the output. Or we can define some other invariants in our code. For example, you can say if we reverse something, the length of that thing should be unchanged. Or for example, you can say if we reverse x, the first character of this string should go to last place. And the property-based testing works in this form. We should define the property with libraries that we will see in this video. It will generate many inputs, maybe thousands of inputs for that test automatically, not by yourself, and then check the property. For each input, it will iterate and check the property is valid or not, and then find the bug automatically. In here, we have a very important sentence. If it fails, the tool finds the smallest failing input. We called it shrinking, and we will see that. I promise that we won't talk about AutoFixture, and maybe this question comes to mind: what is the difference between property-based test and AutoFixture is a very useful tool, but it's not for property-based testing. It's a completely different with different aims. In AutoFixture, you want to create the inputs automatically. For example, you have a test and you want to decrease the effort of writing the test, and with AutoFixture you can create random data for that. But in property-based testing, we verify property against many inputs and automatically. The main key in here is not the input, is the property, is the rules. We write the test against the invariant of the domain. And also in AutoFixture, we don't have shrinking. What is shrinking? We will say. And the goal of each of them are different. In AutoFixture, the goal is to help you arrange test data, but on the other hand, we write property-based tests to break your property. And the usage of them are different too. The usage for AutoFixture is building complex object easily, but on the other side, we want to validate domain rules, algorithms, value objects, and these kinds of things. Maybe when you want to start to write properties for your test in this approach, sometimes in the beginning steps, maybe you can't find the good examples for the property. And these common patterns maybe help you to can brainstorm about the domains and find the similar things in there. The first one that is very popular is round trip. If we apply that method, that SUT, system under the test, it should return some specific step. For example, it should come back to the beginning state. In the deserialized serialized form, you can see that more than some other things. For example, if you serialize X and then again deserialize it, you should get X as a result. This is similar in encoding and decoding, in compress, decompress, in encrypt, decrypt. The second one is idempotency. This is very popular things in the financial systems or many other systems, for example, in reservation and these kind of things. If you do that multiple times, the state should be same with one specific action. If you reply the action, it will be stay in same state. And the third one is commutativity. Commutativity comes from math. It means that if you change the sequence, the result should be same. For example, A plus B should be equals to B plus A. Another thing is invariant. Invariant is the most important one. And usually the properties stays in this part. What does it mean? It means some rules that dominate on that method. For example, if we sort something, we shuffle something, or we reverse something, the count of that string should be same. Or for example, the count of the array of the numbers or the sum of the count of numbers should be same. If you put in array 1, 5, 3 and 1, 3, 5, the sum of items of this array should be unchanged. The next one is identity. Usually we have one natural item, an element in some collections which it can't change the state. For example, in x plus 0, 0 is an element that can't change the result. So this is one property that we can apply in our tests. And the last but not least is monotonic. What does it mean? For example, if you have one bank account and in where you deposit or withdraw, the balance should be changed. I tend to wonder after finding this hammer, everything seems as a name. And because of this, I bring this slide in here, where it should be used and where it is excellent fit and where we shouldn't use it. In the business logics, in business rules, in the algorithms, in the domain invariants, in financial calculation, in value objects, in collections, in parsers, in serializers, in compilers, in the logic of date and time, and rule engines, and wherever we have a very heavy logic that we should test a wide range of the inputs, it can be excellent fit. But in other places like UI testing, controller, API endpoints, repositories, loggings, or infrastructures such as email sending, database connectivity, external services, and these kind of things, we usually not worth it to use. Maybe one mistake usually comes to work and in implementation, and it is about using PBT, property based testing, instead of other things, using PBT instead of AutoFixture. We saw this is not true because AutoFixture can't be replaced with PBT and vice versa. And also unit tests. Unit tests can't be replaced with PBT and vice versa. But how many tests should be implemented in PBT and how many should be implemented in unit and example based and this kind of thing, and how many should be implemented in integration tests. In here you can see unit tests will occupy the most capacity of our tests, and we don't want to touch integration tests, but we should add some tests about property-based tests. It means that almost 10% of should be in the property-based form. This is not invariant. It can be in some project 5%, in some project 10%, but heuristically, usually less than 10% is enough. Okay, I think it's enough. Now we can jump to code and see very simple, small code example and the usage of the library in here we have very simple class with one simple method with name of normalize. In here we get the username and check if it's null. We want replace it with empty, and after that, for example, trim it and change it to lower. And in test methods, we have one test in a example based. You can see normalize, trim, and lowercase user. It gets one asserted. And we see some property based examples. As an instance in here, you can see normalize is idempotent. That was very common pattern that we already discussed about it. What does it mean? It means that if we normalize this x twice time, once and twice, these two things should be same. Another property, normalize username has no outer white space. If we normalize x, the result should be trim. The last one, normalize username is lowercase. If we get x and normalize it, we should see all the characters in the lowercase. Let me run the test. Okay, all passed. But imagine that one developer will refactor these methods, and this method is very complicated and complex method. What we should do in there? For example, one person forgot to add that null checking, and in the refactoring we missed that. And let me run the tests again. You can see the only test that passed is the example one. So this example test couldn't catch the bug after refactoring, but the property bases can do that. Another thing that is very important here, the message of the test. In here you can see after 14 tests we can get these bugs. It means that 14x was injected as input in this method, and after that we got that the null input caused this method to fail. That's good. But in here you can find zero shrinks. What does it mean? It means that after hitting the method with null value, we understand null is that exact input that we need to violate the domain rule, and no need to decrease the scope. Can we find something that is more than zero? Let me try. Let me revert this and, for example, remove trim one and run the test again. Okay, for example, this one, yeah, good example. In here you can see after 8 tests, after hitting the test method more than or not more than equal to 8, we could find the input which can violate and fail this test. What was that input? That input was white space HD. If we hit the method, the test method with this input, we can fail the test. But maybe some character in here is not useful. What we should do, we should shrink that and decrease the scope to find exactly input which caused that issue. So after 2 shrinking, it decreased. For example, first it tried to remove D, and then it tried to remove HD. And then it could see that this input is the real issue of our test. So we could find the exact point of the issue, the exact point of the bug, not the area of the many inputs that can cause that. This is the excellent approach that can make confidence in developer to refactor the code, and it can be understand everything is in its place. That's very useful, isn't it? So try it in your project and write your feedback in the comments and hit like. Bye bye.